Hello and welcome to week 4 of Neon Dev Bootcamp. This week we are going to look at the SPL Token Library created by Neon EVM to create and initialize an SPL token mint from Solidity contracts and interact with it later. And also we are going to look how to create associated token accounts and arbitrary token accounts with the help of this library from our Solidity contract. And we'll also discuss the differences between the two accounts, associated and arbitrary, and in which cases we need the first and the second. And of course, we'll start by looking at the differences between Ethereum and Solana token standards. As you already know, in Ethereum, tokens are just smart contracts that implement a shared interface. And the most common, of course, is ERC20 for fungible tokens, but there are many more standards on Ethereum as opposed to Solana, where there is basically one token standard and one token factory, the SPL token program. So the user balances on Ethereum are stored in the contract as mappings, as opposed to Solana, where they're stored in separate token accounts. Then the token account creation happens implicitly on Ethereum, and basically one contract means one token. And the Ethereum account model is flat, which means that each user address interacts directly with token contracts. And for Solana, we are going to have to explicitly create token accounts that are going to manage the tokens. Delegation and approval happens also in different ways. For example, we have a simple approve method in Ethereum, and on Solana we are going to require unique delegate per token account, and we are also going to have separate kinds of accounts. And as we mentioned earlier, tokens on Solana are created by the SPL token program, and token programs contain all instruction logic for interacting with tokens on the network, both fungible and non-fungible, and all tokens on Solana are effectively data accounts owned by a token program. So we have a mint account that represents a specific token and stores global metadata about the token, such as the total supply and mint authority, that is the address authorized to create new units of a token. And this account acts as a global counter for a specific token and stores data as supply, which is the total supply of the token. It has the decimal precision of the token, and you also specify the mint authority. It also has a freeze authority. And a token account tracks individual ownership of tokens for a specific mint account for a specific owner. And it has data such as mint. Basically, the token account holds units of this amount of mint. Then owner, the account authorized to transfer tokens from the token account, and the amount. Now, if we compare them and see how they're used in reality with regards to ownership, we are going to take, for example, a wallet. And a wallet is going to need a token account for each token mint it wants to hold, and the wallet address is going to be set as the token account owner. And each wallet can own multiple token accounts for the same token mint, but a token account at the same time can only have the owner and hold units of one token mint. And there is another type of account that is called the associate token account. And this kind of account simplifies the whole process of finding a token account's address for a specific mint and owner. So you can think of the associated token account as the default token account for a specific mint or owner. And an associated token account is created with the help of a PDA, program derived address, and a PDA derives an address deterministically using predefined inputs, making it easy to find the address of an account. So this way, an ATA is created with an address derived from the owner's address and the mint account's address. It's important to understand that an associated token account is just a token account with a specific address. Don't confuse ATAs with arbitrary token accounts. These are not user-facing accounts, the latter ones. You won't find them in your Phantom Wallet or SolScan, for example. They are only developer-facing, and they're used by developers in cases when you need, for example, to assign different delegates to claim tokens or split balances across accounts. So moving on to how the SPL Token Library helps us interact with these tokens, let's see how this process relates to the library we discussed last time, the System Program Library. So before you initialize a token account on Solana, you first need to create an account using the system program. And in Neon, we wrap that logic using the create resource method or create account with seed, which we discussed last time. So basically the relationship or the pipeline is as follows. First, you use the system program to create the account, and then second, you use the SPL token program to initialize it as a token account or a mint account. So without the first step, Solana doesn't recognize your account as a token account. And to help us interact with SPL tokens from our Solidity contracts, Neon created these libraries, the SPL Token Library and the Associated Token Program Library, which let us encode Solana-compatible instructions from Solidity contracts. So the SPL library handles token minting, transfers, and account actions. And the associate token program focuses on a special kind of token account that simplifies wallet interactions, the associate token account. So these libraries all follow consistent architecture. As you've seen before with the previous library, this one also has errors, formatters, and data helpers. The errors are going to map Solana errors to Solidity errors so that they are easier for you to handle. The formatters are going to build Solana compatible instructions, and the data helpers, the getters, are going to help us read and return key data in the EVM readable format. So, and plus, again, we have a test script. And in this test script, there are over 30 automated tests to verify the instructions we are going to see in the libraries. So you can run them locally to see how the instructions are built and passed to the precompiled contract. So the script has, for example, create and initialize new SPL token mint test. Then it's going to be creating and initializing the ATA. Then we're also testing the creation of an arbitrary account, and basically everything you need to interact with SPL tokens from the Solidity contract. Now let's go through this library and see what kind of instructions it generates. First of all, it's going to help us initialize a mint. We are going to pass the decimals, token mint, mint authority, and freeze authority to initialize our mint instruction. So the token mint accounts are going to be initialized as well later. And yes, to do this, we have the second instruction, format initialize account. And for this, we have the associate token account, the token mint, and pass the mint account of the token to be minted and the account which has been granted authority to mint this token, and the recipient ATA, which is the associated token account to which the token will be minted. And of course, the amount which is going to be minted. Then we'll also have a transfer instruction here where we specify the sender and recipient ATAs. And then we have a set authority instruction where we are gonna basically update an SPL token mint or freeze authority, or close or change the owner. So this is basically the setter of the authority with which we are going to be able to play later if we want to change it or close it. Then we always have to have this approve instruction to delegate the balance of an associated token account to a third-party account, and that is why we have this format approve instruction. So we specify the ATA that we want to delegate, then the delegate is the account that we want to delegate to, then again the owner of the associated token account that we want to delegate, and the amount of tokens that we want to delegate. Again, speaking about authorities, here we also have the revoke instruction, which is going to revoke the delegation which was granted by an ATA. And also we have an instruction to burn the tokens from a token account, the burn instruction, and as we mentioned before, we have the close account instruction as well, and also sync native instruction if you want to sync a wrapped SOL token account's balance. So these are the instructions that you're going to get here. And also in the SPL token data file, you're going to see a lot of getters in order to read the data, for example, in your UI. So here you have such getters as SPL token mint is initialized, which basically shows you the token mint, the 32 bytes SPL token mint account public key. And this is a boolean which shows you if it's true or not. Then get SPL token supply, and here you get supply as an unsigned integer. Then you get SPL token decimals, which you can also pass to a UI. Then the mint account public key, which you're going to need, and SPL token mint account public key. Then all kinds of data. Then yes, so this token mint getter, get SPL token mint data, is basically a more condensed way to get all this data that we've seen previously. So if you want to receive and read all these all this data, you can use only one getter instead of several ones to save space. Then another important one is getting the SPL token account owner and SPL token account mint. So if you scroll a bit later there, you can see that yes, you can again take all of this data in one getter. So if for your UI you need these different kinds of data to be pulled, you can just use a more condensed version. Okay, then we also have the errors file, which is going to show you the Solana errors in the way that EVM developers are more used to, so that you can handle them. And so then here we are not stopping just at the SPL token library, because the associated token program library is also connected to what we need to do, basically to create and initialize the token mints, because as we've said before, you also need to create the associated token account. So it has a create instruction to create your ATA derived from a token mint account public key. And then, as usual, we've created an example contract that uses the SPL Token Library and the associate account library to basically build the token program instructions and create token mint, initialize it, transfer, and basically perform all the actions that you're going to be able to perform from Solidity contracts through these libraries that we've seen. So this contract uses iCall Solana precompile, which is one of the building blocks of Neon's composability feature, and it creates accounts, it builds Solana compatible instructions, and it also executes them directly from this contract. And so basically we use the SPL token program library to build token program instructions, the SPL token data to read data from Solana token accounts, and we also use call Solana helper lib, which formats instructions for execution. So here, once again, we create a token mint account using call Solana create resource with a sol derived from message sender and a custom seed. This is basically create with seed instruction. Then we initialize it with initialize mint and assign the mint and freeze authority to the contract itself. So we are going to use the mint and transfer functions first to mint tokens from the contract as our mint authority to a recipient ATA, and then a transfer function that's going to move tokens from a sender's arbitrary token account to a recipient ATA. And since Solana token accounts have authorities, here this contract lets us update token mint authority, which is going to update the mint or freeze authority of a token mint, and the update token account authority, which changes the owner or closes the authority of a token account. So let's also see, yes, it also has the approvals, and similar to ERC allowances, these approvals, these methods, for example, approve method allows a delegate to spend tokens from a user's token account. The claim method lets the delegate transfer approved tokens, and the revoke approval revokes that delegation. And so finally we have the claim function that verifies that the registered delegate and that the approved amount is sufficient. And finally we have just a couple of housekeeping functions like burn that destroys the tokens in an account, close token account that reclaims the sol rent from an account, and sync wrapped sol account method which syncs the balance of a wrapped sol account with the underlying sol. So these basically help us clean up and maintain the token state. And the second half of the contract includes the getter functions. For example, the token mint info with the get SPL token supply, token account info with get SPL token account balance, an account owner, and some authority tags and full data readers as well. So yes, and it also includes two utilities. First, get associated token account, which returns our ATA, and get arbitrary token account, which returns this developer facing nonce-based custom account. And these getters are going to be very useful to you when you're going to build a UI or a dashboard, or even when you're debugging the contracts. So to sum up, this example contract allows you to use this composability layer to create, manage, and interact with SPL tokens on Solana. So what you can do is, first of all, you can run the test script, which contains a lot of tests, and follow along to see how the token mint is created and see how the ATA interacts with it. But the main task will be to try and create an SPL token mint with a new seed and mint tokens from the new mint to an associated token account. So go ahead and research this contract once again to see where you can change the seed to create another SPL token mint and a new associated token account. And as a kind of a bonus task for bonus points, you can go further and demonstrate how to use other functions that we see in this library to, for example, approve a delegate of a new token and let them claim a portion of tokens, or you can burn some tokens from the newly created mint, or you can transfer the mint authority of the new token to a different account, or you can empty and then close an account associated with the mint that you're going to create. So thank you for your time. I'll see you next week.